Our next topic in optoelectronics is LED, that is light emitting diode. The principle of working of this LED is electroluminescence. Electroluminescence is a property of the material to convert electrical energy into light energy. Now in this diagram we can see the symbol of LED, which is just like a conventional PN junction diode. Apart from that, it is going to have arrows above the symbol indicating that it is going to emit light. So these are the different colors of LEDs available in the market. Now this LED, you can see here we are having a longer lead indicating that it is the anode, and will be having a shorter lead indicating that it is the cathode. Construction of an LED. LED basically consists of a p-type layer, n-type layer, and in between we are going to have the depletion region, which is also called as the active region, and the emission of light will be taking place from this depletion region. In this diagram we can see light is being emitted from all the directions. In all the directions from the depletion region, light will be emitted. So this entire structure will be placed in a tiny reflecting cap so that the light which is emitted in all the directions will be reflected towards a desired exit direction. So you can see here in our previous diagram we have this reflecting, this one is the reflecting cup. Now coming to the working of an LED, LED works only in the forward bias condition. Positive terminal of the battery is connected to the p-type of the diode, and the negative terminal of the battery is connected to the n-type of the diode. We know in forward bias condition, a PN junction diode, it is going to allow the flow of current, and when you're connecting in the forward bias, holes from the p-type will be moving towards the junction and the electrons from the n-type will be moving towards the junction. So we can see here in this energy band diagram, the electrons in the conduction band are moving towards the depletion region, and the holes in the p-type region will be moving towards the depletion region. So whenever an electron is moving towards the hole to recombine with the hole, this electron, it is going to emit energy in the form of light. So before it is combining with a hole here, it will be emitting energy, which is the difference of energy between the conduction band and the valence band, that is the energy gap, that is the band gap energy will be emitted, and that energy emitted is in the form of light. So this is how the recombination of electron hole pair is taking place. This is the explanation for the working of LED. Now coming to the volt-ampere characteristics, we are taking the voltage along the x-axis and we are taking the forward current along the y-axis. So these are the graphs we are going to get for different colors of LEDs. So as the voltage is increasing, the current will be increasing. We can see here, say for example, if you're taking the case of infrared light, as the voltage is increasing, initially when the voltage is 0, the current is 0 through the LED because of the presence of the depletion region. Now because when you're connecting in the forward bias, slowly the depletion region will be decreasing and gradually the current through the diode will be increasing. So as the forward current is increasing, the brightness of this light will be increasing in LEDs. Advantages of LEDs, they have fast switching time. The switching times, that is the on and off of this LEDs, can be done within less than few microseconds, and these LEDs will be consuming low power and will be having better control of this LEDs. As I told before, we can control the brightness of the LED, that is the intensity of the light can be controlled by controlling the current passing through the diode, and it is economical and reliable. These LEDs are available in smaller size, so they are portable and they have higher efficiency. Next, the disadvantages of LED: over voltage or over current. The LEDs will be getting damaged when the current is increased beyond a certain limit. Overheating due to radiant power. So the LEDs get overheated with an excessive increase in radiant power, which will be leading to the damage of the LED. Coming to the applications of LED, LEDs will be used as indicator in AC circuits, and they are used in display panel indicators. We can see here it is used in 7-segment displays. These LEDs can also be used in digital watches, calculators, and multimeters. We are using these LEDs in remote control systems and also in burglar alarm systems.